Yep.
Right, welcome back. I am Miss Holly.
And I'm Miss Beth. And today we are going to be going through our probability and set notation topic with some helpful revision videos.
Right, don't forget that these are the formulas that you'll be given. So just make sure you're aware of them and you know how to use them, because you might have to use some of them when answering some of your questions.
Okay, guys, so the first question we're going to look at here is about experimental probability and theoretical probability. So here we have a die is rolled 60 times and shows a 4 15 times. What is the experimental probability of getting a 4? We just pause it. I feel like we need to turn the brightness of the board up. Okay, guys, the first question we're going to look at is about experimental probability versus theoretical probability. So our question is, a die is rolled 60 times and shows a 4 15 times. What is the experimental probability of getting a 4? Okay, so let's focus on this part first. So our total outcomes is 60 times. We're rolling this die 60. So our probability of getting a 4 would be equal to 15 out of 60. Okay, you can simplify this to, let's see, we would get 5 over 20, which is, of course, 1/4 or 1/4. Okay, now we are then asked, how does this compare to the theoretical probability? So this is all about, in theory, what should happen. Okay, so if you have got a die, we've got 6 sides to the die, and if it is unbiased, the probability of landing on any one of those sides should be 1/6. Okay, so the theoretical probability would be equal to 1/6, okay? So in terms of how do these compare, okay, well, 1/4 is greater than 1/6, okay? And I will let you have a think about why that might be and how that might change if you were to conduct this experiment with more rolling of the dice, okay? Okay, our next video is about set notation. So we are told the universal set is all integers between 1 and 20. Set A contains the prime numbers from 1 to 20. Write set A using correct set notation. So we want A, and we're going to put is equal to. Remember, you have your curly brackets for a set notation. So we want set A is equal to all values of x such that x is prime and x is equal to or greater than 1, less than or equal to 20. And then remember to close, oh, that was terrible. Remember to close your curly brackets, okay? Let me just do that again. Okay. All right, so now answer the following. It is going to help if you actually write out this set. So I would write out that A is 2, 3, 5, 7, 11, 13, 17, and 19. They are all my prime numbers between 1 and 20. So the number of elements in A is going to be equal to 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then we were asked the number of elements that are not in set A. Now remember that this universal set is all integers between 1 and 20. So if there are 8 numbers that are in set A, there would be 12 numbers that are not in set A. There we have it.
Hi, okay, so this question is a tree diagram question, and yeah, let's do it. Right, so Joe is going to play tennis or squash, and then it gives us the probability if she's going to win or not. So the first one, the probability that she wins tennis, and they represent it by a T, is 4/5. So that means the probability that she doesn't, so I'll write that here with the complement, that means doesn't, is 1 over 5 because probability adds to 1. Then here, the probability that she wins squash, which is represented by the S, match is 7 out of 10. So that means not S is going to be 3 out of 10. So there are probabilities and they've gave us it in the sets. So it wants us to draw a tree diagram to represent the information. So first thing I'm going to do is I'm going to do my first branches, which is going to represent the tennis. So I'm going to put the T here. So this is the probability that she wins for tennis, which is going to be 4 over 5. And then not win is going to be 1 out of 5. So that's our first one. Then the second one is going to be the probability if she wins at squash or not. So this time I need to add both of them because there's going to be 2 different outcomes that she could have for the first one. So here we're going to have that she wins, she doesn't win, she wins, and she doesn't win. So now I can just fill in my probability. So win, 7 out of 10, not win, 3 out of 10. 7 out of 10, 3 out of 10. And these events are independent. Why? Because they don't affect each other. It doesn't say the probability of her winning tennis has any impact on the squash games. So now, to work out this tree diagram, if we're going to actually complete the whole thing, we can multiply the branches together to work out each outcome. Okay? So the first one, the probability that she wins tennis and she wins squash, you would multiply the 2 fractions together. And that is going to get me 4 times by 7 is 28 over 50. Then we can say the probability that she wins tennis but not squash is 4 over 5 times 3 over 10, which is 12 over 50. The probability she doesn't win tennis but wins at squash is 1 over 5 times 7 over 10, which is 7 over 50. And the last one, she doesn't win tennis or squash. You're going to multiply 1 over 5 by 3 over 10, which is 3 over 50. How do you know you've done all them correct? Well, if you add 28, 12, 7, and 3, it's going to be 50 over 50. Right, now I'm going to quickly do these questions here. So work out the probability. So this is an intersection and this is a union. So when you read it, it's asking for the probability that it's going to win at, she wins at tennis and at squash. So that's just going to be the top one, which we've already worked out. So that's 28 over 50. And then the bottom one is a union. So it says tennis or squash. So if we have a look at it, she could win tennis, win squash, win tennis, not squash. She could win not tennis, but win at squash. So basically, it's everything but that bottom one because she could win either or of tennis or squash. So basically, we can make it easy. 1 minus 3 over 50, which is going to give us 47 over 50. And that's it. Okay, right. So this question is talking about counters in the bag. So we have 5 counters that are red and 3 counters that are blue. This says that we're going to choose 2 counters at random from the bag. So that means it's going to be conditional because you're going to take a counter out the bag. So then there's only going to be 7 counters left in the second pick. So it's conditional because they impact each other. So what's the question asking me? Work out the probability that 1 counter of each color is taken. You must show your working. So we can do a tree diagram for this question. Okay, so if I do that. So I'm going to have my picks. So I have pick 1 and I have pick 2. So first I need to work out the probability of getting a red and a blue. So but separately. So the first one is 5 out of 8 to get a red, and the second one is 3 out of 8 to get a blue. So for my first tree here, I'm going to have red, I'm going to have blue. So we're going to have 5 over 8 and then 3 over 8. And then because they pick one out, the second pick is only out of 7. So you have to just carefully follow your path. So if I choose a red, I only have 4 left out of 7, but I still have the original 3 out of 7 for the blue. If I pick the blue first, I still have 5 of the original red left, but it's only out of 7. And then the blue is just going to be 2 out of 7. So that's going to be my tree diagram. Then what I'm going to do is, for this question, it wants me to work out the probability that one of each color is taken. So there's 2 possible outcomes we can have. We can choose a red and then a blue. So the probability of red and then blue. And then you could choose a blue and then a red. Probability of blue and then red. So there's 2 ways we can do this. So we need to first multiply them branches together. So the first one is going to be 5 over 8 times 3 over 7. And the bottom one is going to be 3 over 8 times 5 over 7. So if you notice, we get 15 over 56. And they are the same. So to finish this question off, because it wants the probability of getting one of each, you're going to add them together. So if you add them together, 15 add 15 is 30 over 56.
Okay, guys, we are on to Venn diagrams and probability. So here we have a question. In a group of 30 girls, 12 like milk chocolate, 15 like dark chocolate, 6 do not like chocolate. 1 girl is selected at random. Draw a Venn diagram to find the probability the girl likes chocolate. Okay, so I've started drawing my Venn diagram. So this here is going to represent those that like milk chocolate, and this here will represent the students that like dark chocolate, the girls, sorry. So we know that there's 30 girls in total. I'm told that 6 don't like chocolate, so I know that 6 go on the outside. Okay, now at the moment, I only know that the total of this is 12 and the total of this is 15. So I need to use a little bit of algebra to help me here. I don't know what that intersection point is. So I'm just going to call that X currently. Okay, so then for the girls that like milk chocolate, well, this would be 12 subtract whatever this is. Okay, so 12 minus X. And for the dark chocolate, it would be 15 subtract X. Okay, so I'm going to leave it like that for now. My first question is, what's the probability that the girl likes chocolate? Okay, so if I know there's 6 on the outside, well, 30 subtract 6 would be 24. Okay, I know the total of this here is going to be 24 girls. Okay, on to part B. So given that she likes chocolate, find the probability she likes milk chocolate. Okay, so given that she likes chocolate, so now we're only talking about these 24 girls, okay? So let me just notate this for us, just for a bit of practice. So given that she likes chocolate, find the probability that she likes milk chocolate. Okay, never mind. I'm not going to notate this actually. Let's go back. Let's just we're talking about the 24 girls. So the probability she likes milk chocolate, well, that's 12 out of those 24, okay, which is a half, okay? So the probability that she likes milk chocolate is half, okay? I was going to be fancy and do the nice given notation, but it's not quite going to work there. Okay, on to part C. So find the probability that she likes dark chocolate given that she likes milk chocolate. So now we need to know what this intersection is, okay? So I'm going to create an equation that I can solve. So I know that all of this has to sum to 24. So 12 minus X plus 15 minus X is equal to 24. Okay, I can simplify and solve. So 12 plus 15, 27, minus X plus X, that cancels out. So we're left with minus X equals 24. So I know that X is equal to 3. So now I can go back to my diagram. Let me just rub these out and replace them with the correct values. Okay, so I know that there's 3 in the middle. There's going to be 9 here, and there would be 12 here. an easy way to check is just make sure that that sums to 30. So now find the probability that she likes dark chocolate given that she likes milk. Well, there's 3 in the center. The total for milk is 12. So that's going to be 3 out of 12, which is a quarter. Okay, on to the last part. Maybe I'll come to here. So D, test whether liking milk and dark chocolate are independent events by using theorem 2. So theorem 2 is probability of A intersection B is equal to the probability of A multiplied by the probability of B. So here we would have 3 out of 30 is equal to the probability of A, which is 12 out of 30, multiplied by the probability of B, which is 15 out of 30. I don't think they're going to be the same, but let's have a look. So we've got 1/10 is equal, separate that. 12 times 15 is going to be 180 out of 900, which is not equal to each other. Therefore, they are dependent events. Okay, so to practice our probability and Venn diagram questions, this is an e-assessment question and it is from the 2024 extended e-assessment. So we have NYP Academy is presenting a talent show for their community. Some students from the academy and some members of the community are performing in the show. A total of 175 people will be at the show. In the following Venn diagram, set A represents the number of academy students at the show. Set B represents the number of performers in the show. So question 2A, one person at the show is selected at random. Given that they are a performer, write down the probability that they are an academy student. So given that they are a performer, so we are only looking at our performers, which is set B. Okay, so we're looking at these here and we want the probability that they are also an academy student. So that's going to be 21 out of a total of 30. Okay. Okay, 2B. So 2 of the performers will be selected at random to introduce the show. Determine the probability that they are both academy students. Okay, so again, 2 of the performers. Okay, so we're looking at performers. So on the first pick, okay, I'm going to pick that they are an academy student. So 21 out of 30. Okay, and we are going to multiply this by what the second pick is. Okay, so on the second pick, one of these would have already gone, and we would also have, so therefore we'd have 1 less total. Okay, so it's going to be times 20 out of 29. Okay, grab your calculator at this point to make sure you do your calculations correctly. Okay, you have 420 over 870. We can simplify this to 14 over 29. You will of course be using Desmos, but for now scientific is good. Okay, now we want to show that A and B are not independent. So you're going to use your independent formula. So probability of A and B is equal to the probability of A multiplied by the probability of B. So the probability of A intersection B is 21 out of 175 because it's 175 in total. Now, if these are independent, okay, it will be equal to this probability. So the total probability for A is 85 out of 175. And we are multiplying by the probability of B, so 30 over 175. Okay, I can clearly see that they are not going to equal each other. However, I should show one more step. So 85 times 30, so 2,550 over 30,625 is not equal to 21 over 175. Hence, my event, or you could say the events, sorry. The events are not independent. Okay.
Okay, so in this question, a group of 100 people in an international school was surveyed about if they prefer to read books or watching movies in their free time. And the table here shows that information. So you can see this two-way table, it's out of 100. So then we're getting asked some questions about if a student is selected at random. So the first one, what's the probability it is a girl? So we go here, we go along, there's 50 in total. So you could write it as 50 over 100, but then obviously make sure you can simplify. It can be written as a fraction, decimal, or percentage. The next one says, what's the probability they prefer books? So in this case, we go to this bit here, which is 40 out of 100. So if we simplify that, it's going to be 2 out of 5. And then the last one, what's the probability it's a girl that and prefers books? Okay, so and you have to go to the girls to prefer books, and it's 28. So that one's going to be 28 out of 100, which is 7 over 25. Right, the next question says given. So this is an important word here because you're given a certain group. So given the student is a girl, so we go to the girls column and it's only looking at the 50 people, row, sorry. And what is the probability that she prefers a book? So you can see 28 of the girls prefer a book. So that one is 28 out of 50. And then the last question here, given that the student prefers books, so this time we are going to look at the 40 students here. And it says, what's the probability that they will be a girl? This one is going to be 28 out of 40. So then for this question at the bottom, it says, are the events of being a girl and preferring books independent? Justify your answer. Well, we all know that the probability that of being, I don't know, I'll write it as a girl. Let's put that as G. And prefers books. Let's just put it as that for now. Has to be the probability that it's a girl times the probability that they prefer books. Okay? So in this one, the probability that it's a girl, we already know, is going to be, and I'll write it as a decimal for now. So it's 0.5. And I'm going to times it by the probability that they prefer books, which we've done here, which is going to be 0.4. So that is telling me, I'm going to move that. That is telling me that if I times them together, it should be, if they're independent, the probability that the girls prefer books, which would be 2.25, which we done in this, which we done in this question. 0.5 times 0.4 is 0.2. So they are not independent. And that's it.